In this lesson, we will be explaining the vocabulary of exponents, applying the product of power rule and explaining that product of power rule, and applying the quotient of power rule as well as explaining the quotient of power rule. As a quick review, for exponents, remember that the larger number is called the base, and that is what is being multiplied. The smaller raised number tells how many times you are going to multiply the base together, and another name for an exponent is a power. So if we look at the example that we have right here, which is 2 to the 4th power, remember the 4 tells us that we're multiplying the 2 times itself 4 times, and that would be the way that we would expand 2 to the 4th power or write it as repeated multiplication. So, just a review of how we read exponents. When it is a small raised 2, we can read it as x to the 2nd power or x squared. Sometimes people also read it as x to the power of 2. With the small raised 3, we can read it as x cubed or x to the 3rd power. And with the small raised 4, we can read that as x to the 4th power. Let's look more closely at some exponents. So if we have 3 to the 5th power times 3 to the 2nd power, and we were going to expand those, remember that this would be 3 times itself 5 times, and then 3 times itself 2 times. So if we write that out in expanded form, we would have 7 3's. So we can simplify that, and that would be 3, and since there are 7 of them, it would be 3 to the 7th power. If we are going to take a look at this example, we have 10 to the 2nd power, which if we expand that and write it as repeated multiplication, there would be 2 10's. And then if we have 10 to the 4th power and we expand that for repeated multiplication, we'd have 4 10's. And then if we have 10 to the 3rd power, we're going to use 10 times itself 3 times. So if I wanted to simplify 10 to the 2nd power times 10 to the 4th power times 10 to the 3rd power, I can simply write 10 to the 9th power. There are 9 10's being multiplied together. Let's take a look at a couple of more examples. So here we have 2 to the 3rd power times 3 to the 2nd power times 2 to the 4th power times 3 to the 5th power. So 2 to the 3rd power is 2 times itself 3 times. If I write it out as repeated multiplication, 3 to the 2nd power would be 3 times itself twice. 2 to the 4th power gives me 4 2's, 2 times itself 4 times. And 3 to the 5th power is 3 times itself 5 times. Now remember that multiplication is commutative and associative, so I can multiply in any order that I choose. So I'm going to multiply all the 2's together first. Since there are 7 of them, I can rewrite that as 2 to the 7th power. And then I can multiply the 3's together. And since there are 2 and then 5 of them, that's going to be 3 to the 7th power. Let's take a look at this example. I have 4 to the 3rd, 5 to the 2nd power, 5 to the 4th, and then just a 4. If you recall, if this is just a single number by itself with no exponent, we understand the exponent to be 1. It's a good idea to write that in so that you remember. So when we have 4 to the 3rd power, if I were to write that as repeated multiplication or expand it, it would be 4 times 4 times 4. 5 to the 2nd power would be 5 times 5. Then I have 5 to the 4th power, that would be 5 times 5 times 5 times 5. And then I have 4 to the 1st power, meaning that would be 1 4. Remembering that multiplication is commutative and associative, I can change the order and the groupings. I'm going to put together these 4 4s, so that makes it 4 to the 4th power times 5 to the 6th power, because there are 6 5s. Let's take a look at a couple of examples where we have division. So in the numerator, I have 2 to the 5th power, and if I were writing that out as repeated multiplication, I would have 5 2's. 2 times itself 5 times. In the denominator, I have 2 to the 2nd power, or 2 times itself twice. Now, if you recall, when we have we can simplify something in the numerator and something in the denominator, because it really means division. So we're going to simplify 2 divided by 2, and 2 divided by 2 is 1. 2 divided by 2, and 2 divided by 2 is 1. So what I have left in the numerator is 3 2's, which can be written as 2 to the 3rd power. And in the denominator, I have 1 times 1, which is 1. So if you take a look at our two exponents, what math operation could I use with the two exponents, 5 and 2, to get my final result, which is 3? Think about that. In our next example, we have 2 to the 3rd power. If I write it out as repeated multiplication, I have 2 times 2 times 2. And in the denominator, I would have 2 to the 6th power, or 2 times itself 6 times. Again, I could simplify, and I could take 2 divided by 2, which is 1, and 2 divided by 2, which is 1, and again 2 divided by 2, which is 1. In the numerator, then I'm left with 1 times 1 times 1, which is 1, and in the denominator, I have 2 to the 3rd power. Is there a way that I could use the exponent of 3 and 6 to come up with my final answer? Let's take a look at our last example. 2 to the 6th power. I'm going to write that out in expanded form, which means that I'm multiplying 2 times itself 6 times. And I also have 3 to the 3rd power, so I'm going to multiply 3 times itself 3 times. In the denominator, I have 2 times itself twice, and then I have 3 times itself 5 times, or 3 to the 5th power. So I'm going to simplify. I'm going to take 2 divided by 2, which is 1, and 2 divided by 2, which is 1. And then I'm going to simplify 3 divided by 3, which is 1, 3 divided by 3, which is 1, and 3 divided by 3, which is 1. So if I simplify the numerator, it looks like I have 4 2's left in the numerator. I don't have any 3's left. And in the denominator, I have, it looks like 2 3's left, which would be 3 to the 2nd power. So let's take a look now again at that first example. A 5 and a 2 is my exponents. Do you see that I could also, instead of expanding all of this out, I could keep the base as long as it's the same base, and I could subtract the exponents, 5 minus 2, and I would get 3, 2 to the 3rd power. If I take a look at the exponents of the second fraction or quotient, I could subtract the exponents. 6 minus 3 is 3. And I have 2 to the 3rd power, but it's in the denominator because that's where the larger amount was. If I took a look at the exponents for the 2, I would have 6 minus 2, which is 4. And I have 2 to the 4th power in the numerator. And for the 3's, I have 5 minus 3, which is 2. And the larger amount of 3's was in the denominator, so I have 3 to the 2nd power. So let's take a look at those two rules. The first one is the product of powers rules, and the product means you are multiplying. So if I have two things I'm multiplying together, let's put it in variable form. So if I have x to the m power and x to the n power, where my base is the same, I can keep the base and add the exponents together as a shortcut. Well, I don't always have to write it out in expanded form. Remember, we must have like bases, and the rule is that you're going to keep the base and add the exponents. With the quotient rule, if I have two like bases being divided as the quotient rule, we're going to keep the base and we're going to actually subtract the exponents. So remember that we have to have like bases. We're going to keep the base, and when it is the quotient rule, we're going to subtract the exponents. Let's take a look at some examples of problems. The directions say write as repeated multiplication and then simplify each. So if we have y to the fifth, we're going to write that out as repeated multiplication. Y to the fifth tells us that there are going to be 5 y's. And then y to the eighth tells us there's going to be 8 of those. So now to simplify, we keep the base and we add the exponents together. 5 plus 8 is 13. Let's take a look at the next example. We have k to the second. We want to write that out as repeated multiplication. Then we have k to the eighth. And then we have a k by itself, so that's going to be k to the first power, which means there would be 1k. So when we simplify that, we have k, and we can add up all of the k's together, or simply add the exponents, which would be k to the 11th. You can see that repeated multiplication takes a while, but it gives us a good picture of how many we have, or then we can start to get used to the rule that we keep the base and we add the exponents. Let's take a look at the next example. Remember that multiplication is commutative and it is associative, so we can multiply in any order that we choose and create any groupings that we choose. So when we have 5c to the 12th, that means I have the leading coefficient, or the number out front is 5, and then I'm going to have 12 c's. Then I have my leading coefficient of my second grouping is -2, and I have 3 c's that I'm going to be multiplying together. Since I can multiply in any order I choose, I'm going to multiply my coefficients together first. 5 times -2 is -10. Then I have my base of c, and I'm going to add all of the c's together, which would be 15. So I have -10 times c to the 15th power. Let's see on letter D if we can simply put these together without having to do the repeated multiplication. So we're going to change the order. I want to multiply the leading coefficients together. In other words, the numbers out front. The -3, the 7, and the -2. I'm going to multiply all 3 of those together. So -3 times 7 is -21, times -2 would be 42. Next, I'm going to look at my bases that are the same. So I have g to the second, I have a g, which we remember is g to the first power, and then I have a g to the fourth. So that's going to be g, and I add the exponents. 2 plus 1 is 3, plus 4 is 7. Then I have an h that's by itself, so that's h to the first power. I have an h to the 8th power, and I have an h to the 3rd power. So I have 1 plus 8 is 9, plus 3 is 12. So I have h to the 12th power. And finally, I can't forget about this e that's by itself. There's nothing to combine with it, so I'm simply going to keep the base and the exponent as it is. Notice I had left a little space because generally we would like to write all of our bases in alphabetical order. E, G, then the H. So our final result when simplifying would be 42, e to the 9th, g to the 7th, and h to the 12th. Let's take a look at some division or quotients. So it asks us to write these as repeated multiplication and then simplify each completely. So in the numerator, I have z to the 8th. That means I'm going to multiply z times itself 8 times. 1, 2, 3. And in the denominator, I have z to the 5th power. So I'm going to multiply z times itself 5 times. So we can simplify by taking z divided by z, which would be 1, and z divided by z, which would be 1, and again z divided by z, which would be 1, z divided by z, which is 1, and z divided by z, which is 1. We have 3 z's being multiplied times themselves in the numerator, so that's going to be z to the 3rd, and then 1 times itself 5 times in the denominator, which would be 1. So our final simplified expression is z to the 3rd power. For letter F, we have t to the 4th power, which means we're multiplying t times itself 4 times, and in the denominator, t times itself 6 times. So we can simplify t divided by t, t divided by t, t divided by t is 1, and t divided by t is 1. So in the numerator, I have 1 times 1 times 1 times 1, which is 1, and in the denominator, I have t squared left, t times itself twice. Let's take a look at our next examples. So what we have is 4m to the 3rd, n to the 7th in the numerator, and 8m to the 9th, and n to 3rd in the denominator. So let's write this out as repeated multiplication. I have 4, and then I have 3 m's being multiplied together. And I'm not going to put the dot this time because we remember that multiplication can also be shown when they are side by side. Then I have n to the 7th, so I need 7 n's. In the denominator, I have an 8 with 9 m's. And 3 n's. And now we can simplify. 4 goes into 4 once, and 4 goes into 8 2 times. I have 3 m's in the numerator, which can be simplified with 3 of the m's in the denominator. And then I have 3 n's in the numerator and 3 n's in the denominator that can be simplified. So what I have left in the numerator is 1 times n, and there seems to be 4 of those left. So I would have n to the 4th power left in the numerator. I have a 2 in the denominator, and I have 6 m's left in the denominator. So my simplified expression would be n to the 4th, 2m to the 6th in the denominator. Let's see if we can do this expression without the repeated multiplication. So the first thing to take a look at would be the a's. Notice there are more a's in the denominator, so that's where our a's will be left. And if I take 7 minus 3, that would be 4, and those 4 a's then would be left in the denominator. Now with my b's, I have b to the 1st and b to the 5th. There are more b's in the denominator, so that's where my base will be. 5 minus 1 would be 4, so that would leave me 4 b's left if I were to simplify with my repeated multiplication. Lastly, I have a c, and notice that there are 9 c's in the numerator and 4 in the denominator. 9 minus 4 means I would have 5 c's left in the numerator if I were to have expanded and write it out as repeated multiplication and then simplified. Or in other words, if we use our rule, we're going to keep the base and subtract the exponents. Let's take a look at a couple of more examples and see if we can do them without doing the repeated multiplication. So I have 4m to the 3rd, n to the 7th in the numerator, as well as n to the 4th. And then I have p to the 8th, negative 12, m p to the 2nd. So the first thing that we're going to do is we're going to take off the parentheses and rewrite the numerator as one expression and the denominator as one expression. So I have 4 m to the 3rd, and then I have 2 sets of n's that I would like to combine together. Remember, we're going to keep the base and we're going to add the exponents. So I have 7 and 4, which gives me 11 n's that I'm going to put together. In the denominator, I'm going to put all of this together by multiplication. So I'm going to start with my leading coefficient, which is negative 12. Then I have an m, and then I have 2 sets of p's that I'm going to combine together by multiplication. Remember, when we combine them together, there are 8 p's and 2 p's, so I can simply add the exponent, which gives me 10. Now I'm going to take a look and see if I can do any simplifying. It looks like I could simplify the 4 and the negative 12. 4 goes into 4 once, and into negative 12, negative 3 times. The n and the p don't have anything to simplify with, but the m's do. So there are 3 m's in the numerator and 1 m in the denominator. So if I were to keep the base, the m, and subtract 3 minus 1, that would leave me with 2 m's left in the numerator. I still have my n's, n to the 11th. I have the negative 3 left in the denominator. I've taken care of the m's already, and now I also have p to the 10th left in the denominator. For letter J example, we're going to do another problem where we take our shortcut using our rules. So, first of all, I have k to the 12th and k to the 2nd. If I were to write those out as repeated multiplication and expand them, then I'd have 12k's and 2k's being multiplied together, and I can simply multiply by adding the exponents. 12 plus 2 is 14. I have m to the 6th and l to the 9th still left in the numerator. In the denominator, I have l to the 3rd and m to the 10th. So we're going to finish simplifying using our quotient rule. In the numerator, I have k to the 14th, and I do not have a base of k in the denominator, so that's going to stay as k to the 14th. In the denominator, I have l to the 3rd, and in the numerator, I have l to the 9th. So if I were to write those out in expanded repeated multiplication, I'd have 9 l's on the top and 3 on the bottom. There are more L's on the top, so that's where my base will end up. And when I simplify, I would subtract 9 minus 3. That's going to leave me 6 L's left. The M's, I have 6 M's in the numerator, and I have 10 M's in the denominator. So there will be more M's left in the denominator, and I can subtract the exponents 10 minus 6, and I would have 4 left after I would simplify. So to review, remember for our vocabulary, the base is the larger number that is being multiplied. The exponent tells us how many times to multiply, and power is another name. Remember, you need to have the same base in order for our power and quotient rules to work. Our product rule is if we have the same base, we can add the exponents together when we are multiplying to take our shortcut. And if we are dividing and we have the same base, we can subtract the exponents as our shortcut rule. Please remember to do the reflection.